what's all this about WebAssembly? So I'm here to share some stuff about WebAssembly with you today. So when I started working at Mozilla, I heard people talk about this thing called the web platform, and I kind of was like, okay, those are words. But I think it's actually a pretty significant way to think about what we actually do as web programmers. And I think a web platform is sort of poorly named. It should actually be the web application platform. And thinking about the websites that I was making as applications rather than just websites was sort of a fundamental shift in the way that I thought about the work that I at least used to do. I'm not really very much of a web developer anymore. And so that got me thinking about why is this like platform name significant? So in order to understand words, we need to actually define what they mean. And platform is one of those buzzwords that no one understands. So I'm going to give you my own definition, and this is what I'm going to use for this talk. So many platforms consist of these three parts. So there's an ISA, which is an instruction set architecture, a runtime environment, the API that you get, and then tooling to help you build stuff. So these are kind of also just a bunch of meaningless buzzwords, so let me give you an actual example and maybe this will make a little more sense. If we think about a Unix running on an x86 machine, then the instruction set is x86 assembly. That's how you interact with the actual hardware, right? And then the runtime is Unix. You don't normally think about your operating system as being a runtime for your applications, but that's what it is. Just like you write an application in JavaScript and run it on Node that runs on your computer, if you write an application for the Unix operating system to run on your computer, it serves the same purpose. It's the libraries that you use to interact with the base system. And then you have tools like Shell, the C programming language, and GCC, the C compiler, and all that kind of stuff. So you need these three things to build up a particular platform. Here's a different case study that's like maybe a little more similar to what you're used to thinking of, and that's Java. So in this case, the instruction set is the Java bytecode, and the runtime is the JVM, and the tooling you have is Java C, or maybe Scala C, or Clojure's compiler, whatever they call it, I forget. Or whatever else. And so all of these different, you can run non-Java programs on the JVM platform, right? We think about those things. We had the Grail talk earlier, just mentioned too. So, what's interesting about the web as an application platform is that it was developed totally out of order from the way that people usually do these things, and it's had missing pieces historically. So I put these in a 1, 2, 3 order because it's kind of like low level to high level in a certain sense. You have the CPU, and then you build the assembly instructions to make the CPU go, and then you build the OS on top, and then you build the tooling on top of the OS. But before I talk about like how the web platform fits into this dichotomy, or not dichotomy, but like ontology, I guess. One weird way in which the web platform developed is that usually you build your platform for a computer and you add networking to make it work on multiple computers, but the web platform was built for multiple computers and then only recently really made applications that work on just your own computer. I don't have time to get into the semantics of this and all the details because I only have 10 minutes, so you can talk to me later about this, but it's an interesting aspect of the way this works. And so, to make the web platform more interesting and to like fully explore its possibilities, we have to fill in these missing pieces in the platform. And so in this case, the instruction set architecture, we don't really have one. The runtime is JavaScript and the JavaScript VM, and also the web platform APIs that the browser provides to you. And we have lots of tools, maybe too many tools. There's a lot of tools, and the tools work on tools, and it's amazing. But we're missing this first part, that is the low-level aspect of the platform. So we started kind of like in the middle, but we don't really have the lower part of the stack. And so that is what WebAssembly is. WebAssembly is the assembly language of the web. So the same way that most people don't write assembly language, they write a higher-level language and then compile it to an assembly language. We have traditionally only had the higher-level language, being JavaScript, and we've never had the lower-level language. One weird thing about this analogy is that JavaScript does not compile WASM. Just ignore that. It's fine. I don't have 10 minutes. So historically, like the web can only handle very high-level tasks. So we're making like fancy UIs and doing these kind of like certain things. But one of the things I'm excited about with WebAssembly and developing the web platform further is it allows us to do lower-level tasks. So for example, we've heard WebUSB is my pet favorite, like interesting new feature in the browsers is that you could like access a USB drive from your browser. And that's like a lower level thing, like a USB driver, but we can do it from inside a web browser, hopefully in the future, it depends. And so what this means is we fill out the web platform in general, is that it's closing in on kinds of applications that were previously only possible in other platforms. So for example, like offline only web apps feels contradictory unless you think about the web as an application platform. And usually, as I mentioned earlier, right, things used to be offline and online got added. We're making things that used to be online work offline. And that has all sorts of implications that I can't get into in 10 minutes. So, more about WASM. What actually is WebAssembly? It is a compact binary format to run programs on the web, and also outside of the web. But I only have 10 minutes. This is a factorial program in WebAssembly. Look at it, isn't it so readable? But this is what you would actually download in the browser. So the fact that it's compact is great because that means that you download it quickly, you parse it quickly, and it generally runs quickly, although that doesn't have to do with the binary thing. Oh, lightning talks. However, that code would also look like this. So WebAssembly also has a text format. This is actually one of the two text formats. You may notice this is sort of the revenge of Lisp. I wish I could get into it more. But the point is that you actually have a readable thing you can read if you want to, just like you can read assembly language, you're not always reading machine code with WebAssembly. And so WebAssembly was specifically designed to be really small and efficient and integrate well with existing JavaScript virtual machines. So while there are independent WebAssembly interpreters, usually in the context of your web browser, it's actually the JavaScript engine that is running your WebAssembly code, and that's because JavaScript engines are generally awesome, and all the major ones do a really good job, so why make a whole new thing when you can just use the awesomeness we already have. And a really other important thing about WebAssembly that a lot of people get wrong is that it is explicitly not designed to replace JavaScript. WebAssembly is not coming from your job, for your jobs. Don't worry about it, it's cool. Like, WebAssembly is about augmenting the web and allowing people to do new and cool things, not about like destroying JavaScript. And a lot of people get that wrong, especially people who hate JavaScript, but they're just wrong. So sorry to those people. Great for all of us. So as part of that, you normally don't want to actually be writing this, because this is just like you normally write actual assembly. So what you usually do is you write other programming languages and compile them to WebAssembly. If I had more time, I would tell you about how awesome the Rust programming language is to compile to WebAssembly, but you'll have to talk to me about that later. This is what I'm really excited about, and we're working on making it awesome for a number of great reasons. I'm out of time. If you want the true, like, ridiculous version of this talk, there's a talk by Gary Bernhardt in 2014 called The Birth and Death of JavaScript, and it's actually not about how JavaScript dies at all, but this is the kind of this is the universe I want to live in. And it's a very interesting talk, and you should check it out sometime. It is much longer than 10 minutes. Thank you so much for having me, and I'll see you over here.